Hello. So we're kind of getting close to the end of the probability unit. Um, we have a worksheet, one more worksheet for today, and another worksheet for Wednesday next week. And then on Friday next week, we're gonna have our second quiz already. So let's jump to it. We're gonna first learn what's called the expected value. That's another way of saying what's the average value you get out of this process. And then we have another paradox that kind of goes along with that. So let's do that. Okay. So let's say we have some kind of random result that ends up with a number. So we're going to call the random result it's capital X. And you could think of maybe a die roll, for example. And you have a number of different possible results. Let's say X1, X2, all the way through Xn are possible number that this random result could take. And each of those come with maybe a different probability. Maybe they're all equal or maybe it's different. So probability for getting each result might be P1, P2 to Pn. They could be the same. They don't have to be the same. And then what's called the expected value or long run average value for X is given by this particular formula. So E square bracket X, so this is expected value of X. And what you do is you multiply each of the possible result with the probability of getting that result. And you add them up. So X1 times P1 plus X2 times P2, all the way up until Xn times Pn. All of the possible results with their probabilities. And if you add it up, you get the long run average of what kind of result you expect out of this. So for example, if you're rolling a 6-sided die, you could get 1 with probability 1/6, 2 with probability 1/6, 3 with probability 1/6 if it's a fair die, and so on. If you add it all up, so let's see, 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's 21 divided by 6. That simplifies down to 7/2 or 3.5. So you don't expect to see a 3.5 when you roll a die, but the long run average value for rolling a 6-sided die is 3.5. I hope that made sense. Let's use this as a practice. How would you use something like this? So let's say you want to sell a raffle ticket and you want to come up with a fair price for this raffle ticket. So let's say you could win a toilet paper pack with 30% chance. And I say $18 value just because I just went to eBay to look up how much toilet paper packs are going for. So let's just say this is the value that we take. And the pack of ramen noodles, you could win with 10% chance. And very surprisingly, this was going for $30 on eBay. And hand sanitizer with 5% chance. And this was going for $80 on eBay. So let's say you have these prizes and if you want to do this raffle ticket, maybe you're fundraising. So if you know what the fair price is, then you could charge a little bit more maybe to make money off of it, right? So let's compute what is the long run average expected value you could get out of buying this raffle ticket. So what you do is multiply the values with their probabilities and then add it up. So we get $18 value 30% of the time. So 18 times 0.3, $30 value 10% of the time. So times 0.1, and $80 value 5% of the time. So 0.05. Multiply each of these and add it up, and I get 12.4. So this raffle, on average, is you get a prize, $12.40 on average. So you could go from there how much you actually want to charge to make this fundraising viable process. You certainly don't want to charge under that, then you'd be losing money on long run average. I hope that made sense. Let's jump to the worksheet. Okay. Okay. So the expected value does not appear until the back side of this worksheet, the second page. But here's what the four bears paradox is. So there's two bears, they want to start a family, and then they want to have 4 cubs. And the papa bear prefers boy bears, and mama bear prefers girl bears. So 4 children, and let's say the chances of getting each sex for the baby cub is 50-50. So Papa Bear says, okay, well, we'll likely have 2 bears of each sex, so we'll both be happy. And Mama Bear disagrees, and actually it's more likely that we'll get 3 of one sex and 1 of the other. So before you do any calculations, I want you to kind of just go with your gut feelings. Who's right? Is it 2 of each because it's 50-50? Or is it more likely that you'll have an imbalance of different sex, 3 and 1? And then just let's compute it. Okay. So I want you to first list the sample space. What is the possible combinations of different genders you could end up with? So we're gonna get like a sample space with so one possibility is all girl bears, girl, 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 girl. It could be girl, 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 boy. The order in which you have different sex might matter. So maybe girl, girl, boy, girl, 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 boy, boy, girl, boy, girl, girl, and so on. So I want you to try to list all possibilities that you could have, and then start counting how many of them will have 2 and 2 or 3 and 1 and so on. Okay, so I want you to compute. So it turns out that there's 16 possibilities. So I want you to compute the probability that 2 B's and 2 G's, so that's the probability of having 2 each. So count the number of situation where you have 2 boys and 2 girls, and then divide that by 16. That would be the probability of getting 2 and 2. And for the probability for Mama Bear's claim, 3 B's and 1 girl, or 1 B and 3 girls. So count the situation. You have 3 of one in one or the other. And then count those numbers and then divide by 16. Okay. And then if you can work out these two probabilities, you can work out who's correct, which is more likely in this case. Okay. So I want you to pause this video and finish the first page. There are a couple more questions about it. But I think you'll work it out. It's about independence. All right, so pause the video and please finish the front side and come back to this video. Okay. All right. So on the back side is now actually we're going to apply what we learned about expected values. So the average numbers of boy bears and girl bears you might get. All right, so what I want you to do is first compute. So there's a sample problem that's kind of similar to what we did a little bit earlier about the raffle ticket. So let's say 5% of the time you win $1,000 and otherwise you'll lose $60. So there's small chance of winning lots of money and large chance of losing some money. And expected value could tell you, like, do you, on average, in a long run average, do you expect to earn money or lose money? And once you compute that, now let's go back and apply it to the expected number of boys and girls the bear family will have out of 4 baby bears. So there's 5 different possible numbers of boys you could get. You could get 0 boys and compute the probability of getting 0 boys. So that's the only case that could happen is with 4 girl bears. And then the probability of ending up with 1 boy. So I'm gonna leave this part up to you. Okay, so you could end up with 0, 1, 2, 3, or 4 boy bears. I want you to compute what the probability for each of these things are and work out what the expected number of boy bears would be. And it turns out that if you look at the problem this way, one of the parent bears, Papa bear or Mama bears, will be correct. So it's kind of, depending on how you look at the problem and answer the question, they're both correct. If you're looking at the probability of what they're likely, which is more likely? Do you get 2 and 2 or an even 3 and 1? One of the parent bear is correct. If you look at the long run average of how many baby bear you expect to get, then the other parent is correct. And I'll leave it up to you to work out which parent bear is correct in which situation. But yeah, that's it for this worksheet. I will see you next week. And then on Wednesday's video, I will also kind of list out kind of overview of what we learned in the probability unit and what kind of problems you should be able to solve before the quiz on Friday. All right, I will see you guys then. Enjoy your weekend.